Hey everybody, Mr. Tannen here. Going to see if I could work out this proof for you all, as I mentioned today in class. This has been a little buggy today, but hopefully it'll work. My new system here of presenting my notes. So we're going to look at the quotient rule. So we got the quotient rule here. Um, we have, as we talked about, the low D high minus high D low over low squared. Proof to come on YouTube. So here it comes right now, coming in hot. So we're going to use, we're going to first plug the quotient into the definition of the derivative, and then we're going to rewrite the quotient a little bit. So we have, in this case, a quotient, f over g prime. So we're going to write it into the definition. So my limit as h approaches 0. But in this case, I'm going to have f of x plus h over g of x plus h. And then that's minus an f of x over g of x. And that is all being divided by h. So it looks like on cases we've looked at in the past, here we're just using, though, the function notation, adding a bit to the input and taking away from the original function. So what I'm going to do is rewrite this in a strategic move here. I'm going to pull the, I forgot my limit here, pull my, instead of dividing by h, I'm going to write it as a product, which would then allow me to simplify it in this manner. Let me make sure I'm writing it correctly, then I can give a more robust explanation. So essentially what I've done here is, now that I've moved this h over out of the over to the as a product here, well, now what I could do is get a common denominator by multiplying this left quotient by g of x over g of x to get this first term in this denominator. Then I'll multiply the right term by g of x quantity x plus h over g of quantity x plus h, which is where I got this term, and now they have the same denominator. I'll get rid of all that highlighting. So hopefully you see that. So to make our life a little easier, we move the h in the denominator out to the front as a 1 over h, and we also wrote the numerator as a single rational expression. And this step is required to make this proof work. Now for the next step, we'll need to subtract out and add in an f of x, g of x to the numerator, which I believe is a similar step to one we did in our proof of the product rule. I'm going to switch to this pen because it might be a bit easier for me to read. So here I've got my limit. I've got the 1 over h, and I've got now, as I stated, I'm going to add and subtract the same thing. And I'm going to subtract first, and you'll see why in a moment. I still have the same common denominator. All I did was add and subtract this same term in the numerator here. So the next step again is to rewrite things a bit. So I'm going to go ahead and say that this now equals instead of having the 1 over h, I'm going to then switch the denominators. So I now am then going to have just all of this over here f of x plus h, g of x, minus and plus that product. But now that is just going to be over h, because with multiplication I can switch the order around. It's not changing the value. Note that all we did was interchange the two denominators. Since we're multiplying two fractions, we can do this. And so next, the larger fraction is going to be broken up in a way that I believe you'll be able to see where we may be headed with this. So, again, this is the, I don't want to lose track of what it is that we're finding. So what you'll notice here is all I've done is separate this into two separate rational expressions, both over the same denominator of h. So the first fraction, we're going to get a, now you'll see that we actually have a g of x that could be factored out. And in the second, we have a negative f of x that could be factored out. And what that allows me to do now is take this portion and I could write it as a g of x times f of x plus h minus f of x over h, aha, minus f of x times, well, it's going to switch these signs, so I'm going to rearrange these terms, minus a g of x over h, aha, yes. Once again, I still have this in front, so I've got, if you want me to rewrite it, and this is still my limit. So now, let me erase this over here. That maybe will confuse some people, hopefully not. Maybe I shouldn't have erased that, I'll just, because that was our notes from class. Now that we've done that, well, you can see we could use our basic properties of limits to now just take each limit as a in portions, right? Because we, as a limit, if it's a limit of a product, or we can then just take the limit of each part. So the limit as h approaches 0 of g of x plus h and g of x, well, if this is just approaching 0, that's just going to approach, if we take this first limit, 1 over g of x squared, right? The limit of g of x, if we just look at that part, well, that's just going to be g of x. The limit of this as h approaches 0, well, that's the definition of the derivative, so that'll be f prime of x. Again, the limit of, well, there's no h in there, so that's just going to be minus. And then this limit is the definition of the derivative, so I would get g prime of x. And so you can now see we've taken the limit, so now we can just simplify. I'm just going to get g of x, f prime of x. I'll then put this all back into one rational expression. How should I write this last one? So in the end, you can see I'm ending up with the low function times the derivative of the high function minus the high function times the derivative of the low function all over the low function squared. Low d high minus high d low over low squared. Or, as may be most simply written, could just be g f prime minus f g prime all over g squared. Bada bing, bada boom. And that is the quotient rule. Hopefully that was clear enough. Feel free to pause, rewind, go back. Wow, it took over 10 minutes. It was a lot of writing. Much love, everybody, and hope you're having a nice day.